naming ionic compounds. An ionic compound is made from a metal and nonmetal. And it occurs because of the transfer of electrons. So when you are dealing with binary, meaning just a metal and a nonmetal, not a metal and multiple nonmetals, or a transition metal and a nonmetal, these are the rules that apply. So binary ionic compounds you follow these rules. Metal, nonmetal. You just change the ending to "ide." Transition metal and nonmetal. Those are your two types of binary ionic compounds. So on the first one that you see right here, you name the metal of the cation. Remember that your metals form cations because they lose electrons, which means they're losing negativity, become more positive. And your nonmetals are your anions. They gain electrons, gaining negativity, become more negative. So let's do an example here. Let's say we want to figure out sodium and oxygen. Okay, so sodium is in group 1. That's a +1 charge. Oxygen is in group 2. That's a -2 charge. So to make this compound, I would need to make sure the charges cancel each other out. I know that sodium has a valence electron. Oxygen has 6. So, if I change my color here, I know that this electron is going to transfer to this oxygen, which will then give me sodium ion. However, I still need another sodium because I still have this missing electron. So therefore, I need another sodium to come in with its 1 valence electron and transfer. So then I have 2 sodium ions, and now I have an oxygen ion because the 2 gave up its electron and formed oxygen, which means that I have Na2O. And the way that I would write that is it's binary, metal, nonmetal, not a transition metal, just sodium oxide, changing the ending. Now, if you have a transition metal, things change. So transition metals are in our D block over here, with a few exceptions underneath our staircase, like selenium and lead and bismuth. Also are transition metals. So for example, let's say that we have Fe2O3. So it is not as obvious to look on the periodic table and determine exactly what the charge is. However, you can determine the charge of the anion, the nonmetal, and then figure out what charge the transition metal is. I know oxygen is -2. It's in group 6, so it's a -2 charge. This 2 came from the oxygen. So therefore, another reason, we know that the ionic compounds are transferring of the electrons. So because of the transfer of electrons, there needed to be 2 irons and 3 oxygens to make it a neutral compound. This 3 belonged to the iron. So I know I have iron 3+ and O2-. We don't want to write that as a subscript. You always want to write it as a charge. Now, you do not have to ever write these notes. These are just for explanation purposes. Now, to write that, you would write iron, parentheses, Roman numeral 3, and then just oxide. So the key is when you have binary, meaning just a metal and a nonmetal, you change the ending of the nonmetal, whether transition metal or not, to an "ide" ending every single time. Now, if you have a metal You just write the name of the metal. You do not have to worry about indicating the charge because it's a main group metal. We can figure it out by looking at the periodic table. For example, KCl. We have potassium and chlorine, main group metals. So I would say potassium chloride. Now, when you have a binary ionic compound with a transition metal, then you have to indicate the charge. Your transition metals can exist multiple ways with other nonmetals, so we have to indicate which charge is being used. And then change the ending when it's an anion by itself, just a nonmetal, not multiple nonmetals, to "-ide". So for example, let's do another one. What if we had CuCl2? Now we know Cl is right here, that's -1. Copper's here. Now which copper are we using? Well, when there's no subscript, it's like an imaginary 1. I know chlorine is -1, so there needed to be 2 chlorines to form with this compound, so copper is +2. So therefore, you would write the name copper, the name of the metal, parentheses, the charge, 2, and then chloride.